Alright, so I'm trying to find the arc length of the curve that is represented here. So I will try to express this in Cartesian form, just because my formula for the arc length in a polar coordinate is integral of alpha to beta square root of dx d theta squared plus dy over d theta squared d theta. And to find my dx and dy, I would have to find my x and y. And to find my x and y, I would have to use the formula of x equals r cosine theta and y equals r sine theta, which is also equal to what is given in the notes as f of theta times cosine theta and f of theta times sine theta. So um, I will evaluate these values and find out my x and see what I can do to find the arc length. So first of all, for x, I will have to um, put in the values. So f, and because it's been given that my r is 1 over theta here, I'll substitute 1 over theta times cosine of theta and 1 over theta times sine of theta, and those are my x values. And so now if I want to find my dx value, that would be a derivative of this value right here, which we know is, well, x was equal to um, theta, inverse theta, and then, yeah, that's the right notation, and then cosine of theta. So we'll use the product rule. So the derivative of theta, 1 over theta, would be um, negative theta to the negative 2 times cosine theta plus theta to negative 1, and then times negative sine theta. So if I want to make that, write that out in a like this, that would actually make it a little nicer to look at, like that. So if I also want to get my dy, that would be my y was equal to theta to negative 1 times sine theta. So I'll do the product rule again. So negative theta to the negative 2 times sine theta plus theta to the negative 1 times cosine theta. And I'll write that in a nicer way too, just to see a negative 1 over theta squared times sine theta plus 1 over theta cosine theta. So now that I have my dx and dy values, I will plug these two values in for my formula for finding my arc length. So then I will put them in, um, alpha to beta, and here they gave us the um, alpha and beta, so we'll put pi and 2 pi in, and square root of, and this is going to be long, um, negative 1 over theta squared cosine theta minus 1 over theta sine theta over d theta. So we actually don't need that because I should have put in d theta to this whole thing when I took the derivative of it, so that would actually not matter in this um, equation. So then I'll put in my dy, which is negative 1 over theta squared sine theta plus 1 over theta cosine theta squared d theta. So that's the integral that we want to integrate, and it's not very pretty in my opinion because it just doesn't look that pretty, but I'll give it a try. So integral of pi to 2 pi, this huge thing, um, and a square of this first term will be 1 over theta to the fourth cosine squared theta and then a multiplication of these two by these two terms multiplied by 2 would be plus 2 uh, 1 over theta cubed cosine theta sine theta. That's a multiple sign right there. And plus a square root of this term. So 1 over theta squared sine squared theta. And now that all is under in a bracket, and plus square root of this term right here, which is 1 over theta to the fourth times sine squared theta, negative minus, because there's a negative and a positive, 2 times 1 over theta cubed sine theta cosine theta, and then plus a square root of that, not square root, a square of that, 1 over theta cubed times cosine squared theta, all in a bracket, and that should just extend over there, and maybe I'll put that there just to make it complete. So that is my integral, and if I can make it a little smaller, that might make it a lot easier for me to have it in one page. There we go. Because now we can see that this term and this term will go away, as there's a positive and a negative. And when we put these together, it'd be integral of pi to 2 pi square root 1 over theta to the fourth cosine squared theta plus 1 over theta to the fourth sine squared theta. I'm just writing these two things together because I think there could be something cool to be done with that. And then that plus 1 over theta squared sine squared theta plus 1 over theta squared cosine squared theta d theta, because here we can actually take these two things and make them into two different nice little things, because we can take out the 1 over theta to the fourth out and have a cosine squared theta plus sine squared theta, and then plus we can also take the 1 over theta squared out and have sine squared theta plus cosine squared theta d theta. And this, according to our trig values, is all equal to 1. So now I can rewrite this equation, this integral, as integral from pi to 2 pi of square root of 1 over theta to the fourth plus 1 over theta to theta squared d theta. So hey, we can rewrite this again. Integral of pi to 2 pi and have, what is it, theta squared over 1 squared plus theta over 1 over theta squared. Or we could actually write it the other way, so it's like we can take out this thing and have it like that. Would that be a better way? Would it be a better way? No, let's not do this. Let's just say that we have the I got an email about my makeup test, and that ain't fun. I'll just do this again, because I don't know. Maybe I can rewrite this so it's an integral of pi to 2 pi. All raised to this power. And what does that do? Haha. Ma. Hey. What? What? Meow. Oh my god, that's not what I intended. Where? How do I stop? How do I even? I don't know. I don't know. I mean, this might be a way. Maybe I can like bring this down with like +1 to it or something like that. But I think the way that we can really do it is by using ln and then evaluating it from like stuff this to this and stuff like that. But I don't know how exactly I should get there, but that's as far as I get. And I'm pretty proud that I made that into a 1. And I'm gonna stop here. Maybe what I did earlier was right with like this stuff, and then it was like it was like that. Maybe that was right, maybe, because I could take out the 1 over theta out, but I'm just worried that this won't work because I'm evaluating it from a certain value, so I don't know what to do with that little thing now that this data is out and I don't know what to plug in. Like, do I evaluate it like that? Like, I don't know, so